This just in, sources claim there's an all-new source of energy that is renewable, clean, and cheap. Here to explain everything are Dr. Adams and Dr. Kamile. Welcome, ladies.
Oh yes, it's great to be here, Mrs. Newscaster. So, in the 1700s, anatomist Luigi Galvani saw the link between biology and chemistry when some frogs' legs twitched due to atmospheric electric charges. But it wasn't until 1911 that the idea of a bacteria for electricity was published in a scholarly paper. Since then, people have been using it in homes as a green source of energy, and electrochemical scientists like us are working to make it more accessible and productive.
We have a thing or two to say about microbial fuel. Also, like you said, it's cheap because it consists of rearing bacteria in the ground and allowing the action of them multiplying the power some wires. They feed off the dirt too. So in the general, there's very little to buy except the wires. So go microbial fuel.
Yeah, go microbial fuel.
Woo!
Next is it's clean. As there is pollution created, there's no insane or huge machines necessary, and the bacteria are stored in biodegradable organic matter, so they aren't harming the soil.
Super cool. How is it renewable?
Well, funny story. Bacteria is a renewable resource, and we use, like we said before, biodegradable organic matter to store the bacteria. So the whole system itself doesn't really use any non-renewable items.
Wait, so what exactly is biodegradable organic matter for those of us who aren't scientists?
Well, good question. Yeah, basically anything that can be broken down or decomposed by bacteria, and that comes from nature, and has carbon in it, is a biodegradable organic matter.
Oh, yeah. Thanks for explaining that. It makes a lot more sense.
Oh yeah, I got you.
So, how about you tell us about how it works?
Good idea. Follow us to our laboratory at the Biodesign Institute. Okay, well, here's the biodegradable organic matter, where on the left is the anode and the right is the cathode. The bacteria need fuel to survive, which is where the dirt and other organic material come in. The whole thing is a two-step process, and similar to the powering of a battery. The first step involves the actual removal of electrons through oxidation, and the second step is reduction, where we give those electrons to some outside source that will accept them, which is usually oxygen or nitrate. In this case, though, we transfer the electrons to the anode, where they then move to the cathode through the wire on top, where it is put under a load of protons and oxygen, which in effect creates water, generating a current and voltage to make electricity.
That is complicated, but it sounds pretty cool. How much energy can you get out of one of those things?
It produces up to 15.5 watts of energy.
Ooh, awesome! Anyways, do you see a bright future for this little machine?
It's hard to say. They're still relatively new, but they are gaining a lot of attention right now. So it kind of depends on the level of investment we receive and our quality of research.
Yeah, right now there are researchers all over the world, but the main source of information at the moment is here. At ASU's Biodesign Institute, we are trying to commercialize the use of this alternative energy through some series of tests through the use of tiniest organisms possible. Through our innovations, the MFC could potentially be used to provide energy for large numbers of people at a time.
Are there any disadvantages to this type of energy?
Well, the main issue we have is that it doesn't really produce as much energy as fossil fuels and other alternative energy sources, but it's completely green, and with time I'm sure microbial fuel will be able to produce enough energy to power many homes at a time.
That's really cool. Well, that's all the time we have for microbial fuel cells today, but stay tuned for our next segment